Hello, this is the week 8 Andromeda review. So we'll start here with a little snapshot of the database. The current training set is 3.6 gigs, and inside it we've got around 126K documents. So pick of the hardware setup. Computer on the left here, the black one, is the one doing the machine learning, all the training and running of the model. It's all CPU based right now, but it could also use GPU. There's a GTX 980 in there. Laptop up here is actually storing the MongoDB. I swapped over to use an SSD to get better performance. Luckily, you can just plug it into the USB port, external drive. So there was a minor setback. The MongoDB, so this computer, the laptop here, is set up with the router as a DMZ. So all ports are accessible from the external WAN interface. And that being said, I didn't secure the MongoDB. So February 23rd at about 6:30 in the evening, I had a connection from 209.9.107.171, and they started dropping my databases and then deleting my users. So that was kind of a setback. I was like, well, who is this person? So I look them up on the Whois. They're this address, which is PCCW Global. Okay, well, some telecom company. So I check them out. It looks like they're a global VPN, so one of their customers is probably doing some not so nice things using them as a VPN proxy. I was tempted to call them, but figured they wouldn't really be able to help. The attackers did leave a nice message, though. So they left me a Bitcoin address, an email, an exchange, and a text message saying your data is downloaded and backed up on our secured servers. Blah blah blah. Send us money, and we'll give you your data back. So I thought it was kind of funny. They they dumped like 40 or 50 gigabytes of data, which is kind of useless because, what are they going to do with that? But yeah, it just goes to show, definitely keep your stuff secure. So then I refactored the neural network into a Python class. So now we've got nice encapsulated functions. I'm doing some multi-threaded processing of the data coming in, so we can hopefully get some faster turnaround times. I do need to parallelize the reading of the MongoDB. There's big chunks of time where the process is just sitting waiting for that laptop to query the data and bring it back. So let's see, down here, start training. Yeah, so here we go. I tried to parallelize this by just running this download trade pair as a separate thread, but TensorFlow doesn't really like it if you run multiple sessions at one time because the variables are not reentrant and they'll start stomping all over each other and your machine state just kind of goes to garbage. So you have to use this thing called the queue runner where you batch jobs. So what we would do in theory is parallelize fetching data from MongoDB and prepping it, and then when that data is ready, we would put it in the queue runner so that TensorFlow has a constant workload, and we're also utilizing the fetching of data properly. And then Pleiades is kind of the loader. So Andromeda is a cluster, and Pleiades is another cluster. So this is just what I called the thing that kicks off the actual network. So we can take a look at that. This is Andromeda running on the dual-core laptop with the SSD. Very nice load average. 0.2. It's actually pretty nice. It used to be about 20 because I wasn't using indexes properly. On the other side, this is the thing actually running the training sessions. Right now it's idle, waiting for the epoch to finish or start. So every 5 minutes it'll run the next set of data based on what it's been trained to do. And that data finally makes it back out into a MongoDB with the trade pairs and what their expected value and percent change will be. So we see this Odin slash BTC trade pair got a coefficient of 0.4 and a expected percent change of 9.35%. So then we can use this data on the front end to start doing some actual trading. Yep, so that's it. Thanks. Bye.